Just a minute, children. Sir is joining now.
Yes. What?
Good evening.
Good evening, ma'am.
Good evening, sir.
Yes. Lakshmi. Just give me a
Sir, you
moment.
can start.
Yeah. 1 minute, ma'am. Just give me a moment. Good evening, students.
Good evening, sir.
Yeah. We finished with aldehydes, not aldehydes, alkyl halides, haloalkanes, and haloarenes. I will start with a new chapter, that is alcohols, phenols, and ethers. We'll try to understand alcohols first, and then we will talk about phenols, and then we'll talk about ethers. All these three, alcohols, phenols, and ether, it's been done or classified into one particular chapter. The reason because all three contains oxygen. So if you take an alcohol, the functional group in alcohol is OH. This is alcohol is represented as ROH, where R is alkyl group or aralkyl group. What is this alkyl group or aralkyl group? I will tell you. This is with respect to alcohol. Now, phenols are also represented as ROH, and this R here in case of phenol is aryl group. Aryl group. There's a difference between aralkyl group and aryl group. Now, similarly, ether, the representation is RO, R dash. So all the three contains oxygen. Therefore, this alcohol, phenols, and ethers we are studying under one topic. Now, in case of alkyl groups, we know that from alkanes, if an hydrogen atom is removed, then the corresponding group what we get is called as alkyl group. And the corresponding group is called as alkyl group. For an example, if you take methane, from methane, if one hydrogen is removed, you get CH3. This CH3 is called as methyl group. And similarly, if you take ethane, C2H5, H6 ethane, from ethane, one hydrogen, if you remove, you get C2H5. The C2H5 is called as ethyl group. So R can be alkyl group. When we say aralkyl group, a benzene ring containing a side chain is called as aryl group. It can be any number of side chain. Here we are representing only one group, C6H5CH2. Now, for an example, if we write CH3 and OH, this is called as methanol. C2H5OH, it is called as ethanol. Now here, C6H5CH2OH, this is called as an alcohol. It's called as an alcohol. What alcohol it is called as? It will be called as benzyl alcohol. Now coming to phenols, now R is an aryl group. Aryl group means a benzene ring. So you can see in a benzene ring, this OH group is directly bonded to the carbon atom of the benzene. Whenever OH group is directly bonded to the carbon atom of the benzene ring, then they are called as phenols. Here you can see the functional group in alcohols and phenols are same. Here the OH group is bonded to carbon atom of a benzene ring through a side chain. Since the OH group is bonded to the carbon atom of a benzene ring through a side chain, it will not be called as phenol, it will be called as alcohols. So the difference between the alcohol and phenol is the OH group is directly bonded to the carbon atom of the benzene ring in case of phenols. In case of aromatic alcohols, the OH group is bonded to the carbon atom of the benzene ring through a side chain. But the phenol and alcohol contains same functional group. Now that's the difference between alcohol and phenol. We'll get into the topic now, alcohols. Now what's the function of alcohol? See, alcohols can be used in medicine, like chloroaminophenol, which is used as an antibiotic against typhoid fever. All right, geraniol, it's isolated from roses, and it is used as perfumes. Cholesterol is also an alcohol. It plays a vital role in biosynthesis of steroids. So alcohols are very important compounds. Now, introduction to the alcohols. These are organic compounds in which the OH group is directly attached with carbon. OH group is directly attached. You can see in case of methanol, if I write like this, CH3, the OH group is directly bonded to carbon. If we write ethanol, it is C2H5. We can write C2H5 like this, and you can see again OH is directly bonded to carbon atom. So alcohols are organic compounds in which the OH group, the alcohol groups are attached directly with carbon. And these are hydroxyl derivatives of alkanes, monoalkyl derivatives of water. Monoalkyl derivatives of, mono means one, alkyl derivatives of water. So when I say alkyl derivatives of water, we can write H and OH. If this hydrogen atom is replaced by an alkyl group, you get CH3OH. Therefore, we say monoalkyl derivative of water. The general formula of an alkane is CnH2n plus 2. So if one of the hydrogen is replaced by an OH group, then the molecule what we get is alcohol. You can see CnH2n plus 2. This is the general formula of an alkane. From an alkane, one hydrogen atom is removed and is replaced by what group? OH group. That's the general formula of an alcohol. CnH2n, it's missing here. It's 2n plus 1 OH, or it is CnH2n plus 2. This is plus 2 and O. CnH2n plus 2 and O. So this is the general formula because we have OH group, hydrogen. Right. Next. 1 minute. Next, classification of alcohols. Depending on the number of OH groups, alcohols are classified as mono, di, tri OH groups. If an alcohol contains only one OH group, it is called as monohydric alcohol. It's called as monohydric alcohol. You can also, they are giving monohydric phenol, dihydric phenol, and trihydric phenol. So here, the classification is not only with respect to alcohols, even phenols. The statement clearly says alcohol and phenols may be classified as mono, di, tri, or polyhydric compounds, depending on whether they have 1, 2, 3, or many hydroxyl groups, respectively in their structures. Respectively, and the structures are given below. So this is ethanol. This is ethanol. C2H5OH. This is ethanol. This ethanol is an monohydric alcohol because it contains only one OH group. This is glycol, ethylene glycol. This is called as ethylene glycol. This ethylene glycol contains two OH group. Therefore, it will be an example for dihydric alcohol. What do you mean by dihydric alcohol? Organic compounds which contains two OH groups will be called as dihydric alcohol. And next one is trihydric alcohol. So molecules which contain three OH groups will be called as trihydric alcohol. The example for trihydric alcohol is glycerol. Example for trihydric alcohol is glycerol. And we have polyhydric alcohol. Now, polyhydric alcohol, one such example for polyhydric alcohol is CH2OH, CHOH 4 times, and CH2OH. So this contains 1 plus 4, 5 plus 1, 6. This is an example. It's called a sorbitol. It's an example for a polyhydric alcohol. So more than 3 OH group, it is called as polyhydric alcohol. So sorbitol is an example for polyhydric alcohol. So the first method of classifying alcohol is based on the number of OH groups present. If we have only one OH group, it is called as monohydric alcohol. 2 OH groups, dihydric alcohol. Examples I've given. Trihydric alcohol, 3 OH groups. Example is glycerol and polyhydric alcohol. Similarly, in case of phenols also, if I have only one OH group directly bonded to the carbon atom of the benzene ring, then it is an example for monohydric phenol. It's an example for monohydric phenol. And here you have 2 OH groups attached directly to the carbon atom of the benzene ring. Therefore, this will be called as a dihydric phenol. And you can see here the molecule contains 3 OH groups directly attached to the carbon atom of the benzene ring. Therefore, it is called as a trihydric phenol. Here, this is monohydric phenol. The simple name for this molecule is phenol itself. IUPAC name is also phenol, and it is also called as benzenol, IUPAC name. So this is an example for a dihydric phenol, and this dihydric phenol will be called as 1,2 dihydroxy, 1,2 dihydroxy benzene, 1,2 dihydroxy benzene, and this is commonly called as catechol. It's commonly called as catechol. Now, if you take this molecule 1, 2, 3, 4, so it will be 1, 3, and 4 trihydric phenol. Trihydric phenol. This is the IUP trihydroxy benzene. So it will be 1, 3, 4 trihydroxy benzene. Hydroxybenzene. It's an example for trihydric phenol. It's an example for trihydric phenol. So depending on the number of OH groups, alcohols and phenols are classified as mono, di, tri, poly. Now the next classification, compounds containing carbon sp3 and OH bonds, carbon sp3 hybridized OH bonds. In this class of alcohols, the OH group is attached to an sp3 hybridized carbon. OH group is attached to an sp3 hybridized carbon, atom of an alkyl group, and they're further classified as primary, secondary, tertiary alcohol. So depending on the hybridization of carbon, the alcohol is classified as primary, secondary, tertiary. Now, what is this primary carbon atom? So if we take a molecule like this, CH3, sorry, what happened? CH, here H, and here it is OH. We can call this as primary carbon atom, 1 degree carbon atom. Why I call this as primary carbon atom is because this carbon is bonded to only one more carbon. A carbon bonded to only one more carbon is called as primary carbon atom. This primary carbon atom contains an alcohol group. Therefore, ethanol is an example for primary alcohol. So here they represent, this should be a primary carbon atom. A primary carbon atom will contain 2 hydrogens. Remember, a primary carbon atom will contain 2 hydrogens. Now, likewise, in case of alcohols I'm talking about, if this is a secondary carbon atom, now if I write a molecule like this, CH3, CH, CH3, and OH, it is 2-propanol. 2-propanol. This carbon is a secondary carbon atom. Why this carbon atom is a secondary carbon atom? Because this carbon atom is bonded to 1 and it is bonded to 2. Since this carbon atom is bonded to 2 carbon atom, this is called as a secondary carbon atom. So the secondary carbon atom contains what? OH. Therefore, this is an example for secondary alcohol. So if I write like this CH3 and CH3, this carbon atom is a secondary carbon atom because this carbon is bonded to 2 more carbon atoms. And this secondary carbon atom contains OH group. Therefore, it's called a secondary alcohol. Now, similarly, tertiary alcohol are defined as a carbon atom, OH group bonded to tertiary carbon atom. See, primary carbon atom will have 2 hydrogen, secondary carbon atom will have 1 hydrogen, tertiary carbon atom will have no hydrogen. So a carbon bonded to 3 other carbon atoms are called as tertiary carbon atom. This tertiary carbon atom contains OH group is called as tertiary alcohol. Tertiary alcohol. So we have learned the classification of alcohol based on the number of OH groups as monohydride, and also we are classifying a monohydric alcohol based on the carbon atom as primary, secondary, and tertiary. I hope you followed, students, you followed, both of you?
Yes, sir.
Okay. Now coming to, you should know the examples for primary, secondary, and tertiary. Coming to allylic alcohol. Now what is this allylic alcohol? Now allyl group, you should remember CH double bond CH, single bond CH2. This group is called as allyl group. So if this allyl group contains an OH group, then it's called as allylic alcohol. See, this allylic alcohol also classified into primary, secondary, tertiary. This is also sp3 hybridized. So all we are learning so far, the carbon is sp3 hybridized only in case of alcohols. Now this is an sp3 hybridized carbon atom. See, this carbon atom is also a primary carbon atom because this carbon is bonded to only 1 carbon. So this OH group containing primary bonded to primary carbon atom will be called as primary allylic alcohol. This will be called as primary allylic alcohol. But just observe this. This is an allyl group. Alternate double bond, single bond will be called as an allyl group, remember. And this carbon atom is a secondary carbon atom. Why? This carbon atom is bonded to 1 and this carbon bonded to 2. Since it's a secondary carbon atom and OH bonded to secondary carbon atom, it is an example for secondary allylic alcohol. And you can see this is tertiary. This is an allyl group. Double bond, single bond is an allyl group. And this carbon is a tertiary carbon atom. And since OH is bonded to the tertiary carbon atom, because 1, 2, 3, this carbon atom is bonded to 3 other carbon atoms. And this carbon atom contains OH group. Therefore, it's called as tertiary allylic alcohol. Allyl group, did you understand what is an allyl group? Students? Any clarification so far?
No, sir. Understood.
Okay. Next is benzylic alcohol. Next is benzylic alcohol. What is this benzylic alcohol? This benzylic alcohol also is sp3 hybridized carbon Next, I told you the example. This is an aromatic alcohol. For example, allylic and benzylic alcohol may be primary, secondary, or tertiary. Allylic alcohol we learned. Now just observe, this OH is bonded to primary carbon atom because carbon contains 2 hydrogen. And this carbon is bonded to only one more carbon. Therefore, it's primary carbon. So the name of this molecule is benzyl alcohol. Benzyl alcohol. And this benzyl alcohol is an example for primary alcohol. And this is a secondary carbon atom. Since it is a secondary carbon atom, OH group bonded to the secondary carbon atom, this will be secondary benzylic alcohol. This will be secondary benzylic alcohol because this is a secondary carbon atom. And this is a tertiary carbon atom, and OH group is bonded to tertiary carbon atom. Therefore, this is an example for tertiary benzylic alcohol. Hoping so that the classification of alcohol based on the number of OH group and based on the primary, secondary carbon atom, we have classified. All right. So primary, secondary alcohol, allyl alcohol, benzylic alcohol, we have learned. And this is primarily benzylic alcohol. The name of this is benzyl alcohol. It's an example for primary benzylic alcohol. I hope you understood so far. Now, compounds containing, this is a different one. Now, compound containing sp2 hybridized OH bonds. sp2 hybridized. So that means a double bond. Now, it's an example for phenols. These alcohols contain OH group bonded to carbon atom, carbon to carbon double bond, that is vinylic carbon or to an aryl carbon. And these alcohols are also known as vinylic alcohol. So this is vinyl group. CH2 double bond CH is vinyl group. And vinyl group containing OH group is called as vinylic alcohol. This is an sp2 hybridized carbon atom. Why this is an sp2 hybridized carbon atom? Because the carbon atom is contains double bond. Since carbon atom contains a double bond, it will be called as an sp2 hybridized carbon atom. Now, in case of phenols, you see the OH is also directly bonded to carbon atom of the benzene ring, and this benzene is sp2 hybridized carbon, and this carbon is also sp2 hybridized carbon. All right. Now we learn, this is with respect to classification of vinylic alcohol. We don't learn or concentrate more about vinylic alcohol in the 12th standard. All right. So now we will learn the preparation of alcohol, various methods of preparation of alcohol. The first method is from alkenes. So alkenes. So this is called as acid catalyzed hydration. Hydration means addition of water. Hydrolysis, otherwise it's called as. So this is based on Markovnikov's rule. This will follow Markovnikov's rule. Now, symmetrical alkene will not follow Markovnikov's rule, but unsymmetrical alkenes will follow Markovnikov's rule. We will take an example. Now, this is ethene, CH2, double bond CH2. It's a symmetrical ethene because we can divide this molecules into 2 equal halves. The same thing by acid catalyzed hydration. Here, what they have mentioned as unsymmetrical alkene, we will learn here, right? So when this is hydrolyzed in the presence of water, we write it as H and OH, assume, and one H attacks this carbon, the other OH attacks this carbon. So what we get, you get CH3, CH2, and OH. This pi bond will break. So you get primary alcohol. So when alkenes are hydrolyzed in the presence of an acid, this H plus indicates acid, alcohols are formed. This is a symmetrical alkene. Since it is a symmetrical alkene, it does not follow Markovnikov's rule. Either ways, the product remains the same. One single product you will get. When we talk about acid catalyzed hydration, alkenes reacts with water in the presence of an acid as a catalyst to form alcohol. In case of unsymmetrical alkenes, the addition reaction takes place according to Markovnikov's rule. So when we talk about an unsymmetrical alkene, then the reaction takes place based on Markovnikov's rule. Now, the first step is this water reacts with an acid to form H3O+. This hydronium ion is also called as protonated water. Hydronium ion is also called as what? Protonated water. Now, the first step is, now water reacts with H plus acid to form hydronium ion. The second step is, this hydronium ion being reactive will react with an alkene. So alkene, we will write it as a double bond like this, alkene, CH2, and this hydronium, it is H3O+. We will write H3O+ like this. And this oxygen atom has positive charge. Now you can observe that here, oxygen has a lone pair of electron. Since oxygen has a lone pair of electron, what happens is, now one of the bond will shift on oxygen. When one of the bonds shifts on oxygen, assume that this bond shifts on oxygen. A bond requires 2 electrons. 2 electrons move on oxygen. This hydrogen attacks on carbon. When this hydrogen attacks on carbon, the pi bond breaks and this pi electrons moves on this carbon. Therefore, what is that you get? You get, pi electrons move here. So when pi electron moves here, what happens is, pi electron moves here. No, pi electrons, just one moment. This H plus attacks here. No, this H plus attacks here. So pi electrons also move this side. I made a mistake. One more time, I will write it and explain. I require a little space and we will write it. Now, first step in the reaction is water reacts with H plus to form H3O+. Now, the next is alkene. We have represented it like this for our convenience. Now, hydronium ion, we have represented as H, O, H, H, and you have a pair of electron and oxygen has a positive character. Oxygen has a positive character. Hydronium ion. This hydrogen is positive, oxygen is positive. Now, what happens is, now assume that the pi bond breaks and pi electron shifts on this. Now, when pi electron shifts on this carbon will gain negative charge and this carbon gains positive charge. So what happens now? This bond shifts on this oxygen. Therefore, this hydrogen attacks this carbon. The first step. When this hydrogen attacks the carbon, what we get, I will write it here. Students, I write it here because of lack of space. I have carbon here, not carbon, sorry, a bond here. And you have this carbon atom has positive charge and a single bond here. This carbon, which has a negative charge, is reacted by hydrogen. Therefore, what we get? You get carbon, hydrogen. Already the 2 bond existed. This is nothing but carbocation. Plus, what's the byproduct here? Since this bond is shifting towards oxygen on water, you get water, H2O. Now, oxygen will have 2 lone pairs of electron. See, initially it has only 1 lone pair of electron. Since this bond is shifting here, water will gain 2 lone pair of electron. This is nothing but water. Did you understand the first step?
Yes, sir.
The second step of the reaction is, this is carbocation. This carbocation is reactive. When this carbocation is reactive, there is nothing else to react excepting water. So this carbocation we can represent positive sign. Carbon, this is not a bond here, sorry. Only a bond. Hydrogen, it can be anything. So I have a single bond here. You have hydrogen here, and you have a bond like this. Now this will react with water. Now this will react with water. When I say this will react with water, the pair of electrons is given to this carbon because carbon is positive, and here electrons are negative in charge. So when they are bonded, so what is that product you get? You get a product like this, a carbon, or here two hydrogen. Since it's having a bond, what happens is you get oxygen. Since two electrons are forming a bond, this oxygen will gain positive charge, and you have hydrogen, and you have hydrogen. Along with this positive charge, oxygen will have negative charge. And not negative, what's it? A pair of electron. Two pair of electron, one pair gets bonded. Since the electrons are moving away from oxygen, oxygen gains positive character. Another pair of electron remains as such. And then you have what here? C, single bond H, and already the double bond is existing. Did you follow the second step of the reaction?
Yes, sir.
Now, the third step of the reaction is, now I can write HC, C, not C. The C, it can be C, but anyways, since it's a bond, I'm writing CS regular. And here it is CH, single bond and single bond. Here I have water. This is hydrogen, a pair of electron and a positive character. Now this will further react with water. When this further reacts with water, what happens is, now a pair of electron, maybe, or else maybe I can say in simple words, this hydrogen reacts with water. When this hydrogen reacts with water, you get H3O plus. And you can see this electron shift on this oxygen. When this electron shifts on oxygen, what happens? Oxygen will gain how many lone pair of electron now? Already one pair of electron is there. And since this positive character is there, this bond is shifting towards oxygen. Therefore, this positive character will neutralize with two pairs of electron. So what's the product you get? What's the product you get? You get C. You get what? Now, what else you have? OH. You have O, you have H, and you'll have two lone pairs of electron, already two bonds from carbon, and you have what? Now H, H, and H. This is nothing but alcohol, primary alcohol. So this mechanism of reaction is important. They can ask you, explain the mechanism of acid catalyzed hydration of alkenes. This is important. Mechanism. Did you follow this mechanism? Students, are you there?
Yes, sir. Yes, sir.
Yes. All right. So I'll just reduce the font size for a minute. Kindly you go through this mechanism. This is very important mechanism. So here, what's in the printed material, they've shown carbon on the right side. I have taken carbon on the left side. That's the only difference, but the mechanism is same. We can just go through for a minute, then we will continue further. All right, any clarification? Next, we can go for the next method of preparing alcohols, that is by hydroboration, oxidation. This hydroboration oxidation is also important. We will try to understand this hydroboration oxidation. Diborane. Borane is BH3. Borane is BH3. This borane exists as diborane, B2H6, or we represent it as BH3 twice. Diborane, it's a hydride of hydrogen. So diborane reacts with alkenes to give trialkyl boranes as addition product. And this is oxidized to alcohol in the presence of aqueous sodium hydroxide and hydrogen peroxide. Any peroxide can be used, and the hydrogen peroxide. This is addition of water at double bond according to Markovnikov's rule. So oxidation of alcohol in the presence of aqueous sodium hydroxide and hydrogen peroxide is addition of water at the double bond, and this is according to Markovnikov's rule. This reaction looks very complex, but it is not so. It is easy. We will try to learn this reaction. Now you can see this is an unsymmetrical alkene. Now I will write here. It's an unsymmetrical alkene, CH3. What is unsymmetrical alkene? Can we divide this alkene into two equal halves? Can we divide this alkene into two equal halves? If I write an alkene like this, CH2 double bond CH2 ethene, if I draw a line like this, it is divided into two equal halves. This is an example for symmetrical alkene. So ethene is an example for symmetrical alkene. Now here this is propene. This propene is not a symmetrical alkene. It's an unsymmetrical alkene. When this propene is allowed to react with borane, when propene is allowed to react with diborane, it's wrong here. It is 2. So diborane, we can write it as BH3 twice. I told you. I write like this H, BH2 twice. So what happens? What happens? Now, this is also wrong. We should not show it as 2. We should show only BH3. All right. But in the textbooks also, they've shown it as BH2. You please represent it as BH2. Now, what we will understand is, now this hydrogen attacks this carbon and this BH2 attacks this carbon. So what's the product you will get? The product you will get is CH3, CH2, single bond, no, CH here. You'll get what? A CH. You'll get, no, this also is propene, no, here should be H here. I didn't write. So CH2, CH2 and what? BH2. The product what we get in the first step is CH3, CH2, CH2 and what? BH2. Is it understandable now? Did you understand the first step?
Yes, sir.
Now, if I allow this to react with another propene molecule, if I write like this, CH2, I tell this hydrogen attacks this carbon, and this whole of this group attacks this carbon. Therefore, what happened? Pi bond breaks. So when pi bond breaks, what do I have now? I have a product like this, CH3, CH2, CH2. I have BH, BH. And here what I have now? Again, I have CH2. Here, this hydrogen attacking this carbon. So I get CH2 and I have what now? I have CH3. Understood this? Understood this?
Yes, sir.
This further reacts with another alkene. Why I'm reacting 3 alkenes is because borane has 3 hydrogen. So therefore it reacts with another alkene. So what happens now? This hydrogen attacks this carbon, and this boron, the whole group attacks this carbon. So what will I get? I will get CH3, CH2, CH2. I will write 3 times and borane. See, 1, 2, and this is the third one. So you'll get CH3, CH2, CH2 thrice borane. So what you can do is, we can write this as CH3, CH double bond CH2, 3 moles. When it reacts with borane, you can say it gives a reaction like trialkyl boranes. So it will be tripropyl borane. Tripropyl borane. See here, the final product here is trialkyl borane. Here also we wrote it. Understood this? In one step, you can write. To make you understand, I've written it as a complex. It is not complex. So 3 moles of alkene, propane, reacts with 1 mole of borane to form trialkyl borane. Right. This trialkyl borane, when you hydrolyze in the presence of hydrogen peroxide and sodium hydroxide, what happens when this is allowed to react with hydrogen peroxide and sodium hydroxide? So already we have one OH group here, and hydrogen peroxide, I can write it as, we can write it as, this undergoes hydrolysis here. So hydrolysis, what happens is this boron reacts with water. Water, I can write 3 moles of water. So when we write 3 moles of water, we can write 3H and 3OH. So what happens is boron reacts with water to form H3BO3. That means the 3 not 3OH. This 3OH will react with 1 minute. This 3OH will react with carbon. So this 3OH will react with carbon. This 3OH will replace what boron. So you get CH3, CH2, CH2OH. You get propanol and you get H3BO3. This is called as boric acid as a product, because this 3 hydrogen is there, H3, this is B, and this hydrogen peroxide will give you oxygen, 3 oxygen. So we can write like this. This 3 hydrogen, this boron, and 3 oxygen given by hydrogen peroxide, because hydrogen peroxide is oxidizing agent. So H3BO3, that's called as boric acid. The byproduct is boric acid. So this is called as hydroboration oxidation reaction. So it is a reaction of unsymmetrical alkene with diborane. When unsymmetrical alkene is reacted with diborane, what is the product you get? You get trialkyl boron. This trialkyl boron, when you oxidize in the presence of hydrogen peroxide and sodium hydroxide, you get alcohol, primary alcohol, and you get boric acid as a byproduct. Did you understand this? Students, are you there?
Yes, sir.
Yeah,
Yes, sir.
followed? Yeah, good. The second one is the next method of preparing alcohol. The next method of preparing alcohol is from carbonyl compounds. Now, carbonyl compounds like acids or aldehydes or ketones. All right. So this is wrongly represented here. It is not an aldehyde. They are represented wrong. But anyways, we will learn from carbonyl compound. What do you mean by carbonyl compounds? Any molecule which contains C double bond O group is called as carbonyl. Ketone contains C double bond O, and also you can write aldehyde also contains C double bond. So any molecule, carboxylic acids also contain C double bond O. So all the molecule which contains C double bond O will be called as a carbonyl compound. Reduction of carbonyl compound. What do you mean by reduction? Reduction means addition of hydrogen. Reduction means addition of hydrogen. Addition of hydrogen is called as reduction. Now, if we take an aldehyde, so lack of space, I will try to write it here. I'll erase this and write. Now, aldehyde we can represent as a general representation. I'll take RC double bond O and H. Now, this when you reduce using a strong reducing agent like lithium aluminum hydride or sodium in ethanol. sodium in ethanol. So these are strong reducing agent, lithium aluminum hydride, LiAlH4. Now this gives you a strong, it's a good reducing agent. It's a good reducing. It gives you what? Nascent oxygen, nascent hydrogen. When it gives nascent hydrogen, what happens? Maybe I will represent an alcohol, aldehyde like this. Instead of representing like this for our convenience, we will represent it like this, RCH and double bond O. This is an aldehyde. So what happens is, one hydrogen attacks this oxygen, the other hydrogen attacks this carbon. So what happens? I have RCH, here this hydrogen attacks, and you have double bond. Therefore, what happens? A pi bond will break. When pi bond breaks, you will get a single bond and you will get OH. What alcohol is this? This is primary alcohol. So on reduction of aldehyde using lithium aluminum hydride or sodium in ethanol, alcohols are formed, primary alcohols. So you can write an example. If you take CH3, CH, double bond O, when this is reduced using lithium aluminum hydride, a strong reducing agent, one hydrogen attacks this oxygen, the other hydrogen attacks this carbon. So what will I have? I will have CH3, CH, CH, and OH. This is ethanol. This is ethanol. Did you understand the first step? From carbonyl group, we can prepare an alcohol by reducing aldehyde. Similarly, if you take a ketone can be represented like this. A simple ketone, acetone I will take. This is acetone. This is acetone. This acetone, when you again reduce using lithium aluminum hydride or sodium amalgam, one hydrogen attacks oxygen, the other hydrogen attacks this carbon. So what will I have? I will have CH3, CCH3, H, and OH. What alcohol you're getting? You're getting secondary alcohol. So when ketones are reduced, you get secondary alcohol. When aldehydes are reduced, you get primary alcohol. So aldehydes on reduction gives primary alcohol. Ketones on reduction gives secondary alcohol. Is it okay? Understood this?
Yes, sir.
The next one, and we will stop with the third method of preparation, that is from carboxylic acid. Carboxylic acid. This carboxylic acid is also a carbonyl compound. The carboxylic acid, the general formula will be RC double bond OH. COH, RCOH is called as carboxylic acid. So the actual structure of carboxylic acid is RC double bond OH. This, when you reduce using lithium aluminum hydride, again a strong reducing agent. Reduction is addition of hydrogen. Now this 4 hydrogen, I will write it as 2H and 2H. When you heat this, what happens is 2 hydrogen and 1 oxygen here gets eliminated as water. In place of this oxygen, how many more hydrogen is there? 2 more hydrogen goes. So what will I get? I'll get RCH2OH. It's nothing but what alcohol? Primary alcohol. You take an example. We will take acetic acid. We will take acetic acid. This acetic acid, when you reduce it using lithium aluminum hydride, I can write this as 2H and 2H. So what happened? Hydrogen and oxygen gets eliminated as water. In place of these 2 oxygen, what goes? 2 hydrogen. So you get CH3, CH2, and OH. So this is nothing but primary alcohol, and this is ethanol. Did you follow? Did you follow this?
Yes, sir.
Next, last one reaction, and then we will stop. That is from esters. Esters also contains carbonyl compound. So example for an ester, CH3C double bond O, single bond O, and CH2OH, CH2CH3. It is ethyl ethanoate. The name of this molecule is ethyl ethanoate. It's an ester, C double bond O. See the functional group, COO. This is ester. Now this ester, when we reduce using again lithium aluminum hydride. Lithium aluminum hydride. Now what happens is the bond between oxygen and carbon breaks. 4 hydrogen you have. 1 hydrogen attacks this oxygen. Therefore, you get CH3, CH2, OH. How many more is there? 3. The second hydrogen attacks this oxygen. The other 2 hydrogen attacks this carbon. So therefore, what you will get? You will get again CH3, CH2, and you'll get what? OH. So you'll get 2 moles of ethanol. 2 moles of ethanol, and this is primary alcohol. Primary alcohol. So esters also, when we reduce using lithium aluminum hydride, the product what we get is alcohol. I hope that we finished with the preparation of alcohols. No, we have more methods. We learned Grignard reagent. We have from acetaldehyde, all that, From Grignard reagent, we'll have to learn, and by fermentation. So we'll learn all this in the next class, right? So some more methods of preparation we'll learn in the next class. Ma'am, I'll stop the class. Ma'am?
Yes, sir. Yes, sir. Yes, sir. Thank you, sir.
Bye, everybody.